In chapter 10, we're going to get our nice clean DAO that we wrote in the previous chapter up and running. To do that, we'll need to understand what a data source is. It is standard Java, but you might not have met it before, so I'll give you an overview. The real reason for using a data source is to allow us to plug in production quality connection pools. So again, an overview of what they are and how to use them in Spring. As we're getting a little more serious now, we're going to have to be careful to clean up our resources properly. So a little more Spring theory will give us the very useful init and destroy methods. So here's the code as we left it at the end of the previous chapter. And we're currently still using our old book DAO, which is this horrible JDBC implementation. Now, I want to bring into play my new DAO implementation that we wrote in the previous chapter. So I'm going to go into the XML wiring, and if I just remind myself of the name of our classes, we've got the horrid JDBC implementation that we're now getting rid of, but I'm replacing it for the new one, which I called Book DAO Cleaner JDBC implementation. Now I'm being a bit silly by calling it Cleaner JDBC implementation. You probably wouldn't use a class name like that on a real project, but I'm just emphasizing the role and purpose of this particular class. Now you might remember, if I can go into that class, just to remind ourselves that we have a property in this new implementation of the DAO, and that property is being injected through the constructor. Yeah, and there it is. We need to inject this JDBC template into the constructor. And you'll remember from the previous chapter that this is the helper object that we're using to clean up the DAO code really quite beautifully. All of these DAO methods are just single lines of code. So we need to do that in the XML. Now this template isn't really a DAO and it's certainly not a service bean, so I'm going to create a new little area in the XML, and I'm going to call this area templates, because we might be doing a few more templates later on in the course. So we need to create a bean and give it an ID, and we can call it anything we wish. So I'm going to go for JDBC templates. The problem is, what class name do I need in here? And of course I will need a package name as well. Now this is a Spring Framework class, so we haven't made this name up. Now I don't carry these class names around in my head. Of course I'm going to tell you what the class name is in a minute, but I want to encourage you on this course to get used to working with the Spring documentation. So I've switched across now to the Spring Framework website, or at least at the time of this recording, it's called spring.io, but remember that that might have changed by the time you watch this. And of course, there's masses of information about the Spring Framework on this site. At the time of recording, we go through the docs link, and the project you're looking for on this list is the Spring Framework, of course. And we're looking here at the API for, well, you'll need to choose the correct version, but just at the time I'm recording this course, the current version is 4.0.1. As long as you choose a recent version, you should be okay. And there are pretty much literally thousands of classes in the Spring Framework. I know that the class I'm looking for is called the JDBC template, so I'll do a Control F in my browser and just type in JDBC template, and that jumps me straight to the Java docs for this class. So the first thing I need to know is the name of the package from which it comes, and that's right here. So I'm going to copy that into the development environment. So the class is going to be that package followed by JDBC template. But the real reason we're using this documentation page is we're going to need to find out what properties the JDBC template needs. Now, there are two ways you can do that. First of all, you could scroll down and have a look on the All Methods tab, and you can look for any methods starting with the word set. So for example, we have a method here called setFetchSize. So this is a property that we can configure in the XML wiring. If I click through to that link, it's talking about that this is important if you want to process large result sets. If you set it to a high value, it will increase the processing speed at the cost of memory consumption, blah, 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 blah. And it really is blah because the point is the default has already been set and the default is 0. So actually, we don't have to set the fetch size. And if you have a good read of this documentation, if you're interested, you'll find that all of the set methods have good defaults. I'm going for the set query timeout here. The default is 0. So most of the properties in this class have a default already set, but there is one property that is absolutely required, and we will always need to set it. And for that reason, the Spring team have made this property be injected through the constructor. And if we have a look at this version of the constructor here, it's telling us that it requires a property of type data source. So Spring is effectively telling us here that we need to create an object of type data source and we need to inject it into the template. Now, if I follow the link here to the data source, I don't know if you've come across this data source before, but it is a part of standard Java and not the Spring framework. Have a look at the package name here. You can see it's a standard Java package. Now, the idea of this data source is that it's a kind of wrapper class. It only really has one single interesting method, and that method is called getConnection. It is overloaded for a username and password as well. Now, the idea is that any class that implements this interface is that that class is capable of returning you a database connection using some kind of strategy. And usually on server-based applications, the strategy in use is some kind of a connection pool. We'll talk about connection pools later. Now, the problem with the data source interface, and it's really the thing that makes people think that this interface is a complicated interface, is that there are no implementing classes of data source in the standard Java library. So it's kind of on its own useless. The idea of this data source, the reason why Sun originally put this interface into Java, is that their intention was, and if I put a highlighter on this phrase here, their intention was that vendors, probably database vendors, would implement this interface. So if we wanted to use a data source in our application, we might go off to, I don't know, a company like Oracle and buy a data source implementation from them. Now, I'll talk about that shortly, but don't worry, you're not going to need to go to Oracle to buy a data source. And that's because since Spring 2.5, there's a class in the Spring framework called the Simple Driver Data Source. Let me just find that using my usual Control F in the browser. Here it is here. So here we have the Simple Driver Data Source class, and crucially, have a look here, it implements the data source interface. Now, this is a very basic class. It's just really for testing or development or just getting up and running with your application. And the reason it's not production standard is what will happen is every time we work with the Simple Driver Data Source, every time we perform a database operation, this class will go and acquire a brand new database connection. So let's be clear about this. This is a terrible thing to do on a real application. It's going to perform horribly. Opening a database connection is a very slow operation. So you don't want to be doing that every time you make a call to the database. And they're giving advice here on what we could use instead, and I'll come back onto that later in this course. So why is this class here? Well, as I say, it's intended for testing your code when you're developing. It's a really quick and dirty way of making sure your application's up and running, the wiring's working, and so on. And then once your code is working, we'll be able to change the implementation of the data source without needing to change any of the code for something a bit more production quality. And of course, I'm going to do that very soon on the course. But I don't know if you know what connection pools are, so I'd rather leave those until a little later. It looks like we can use this simple driver data source as a quick way of getting started. Now we'll need to work out what properties are required for this simple driver data source. I must admit, being honest, that one of the problems with the Spring API docs is that it can be a little awkward to work out what properties are required. I can see, for instance, there are two set methods here. They both appear to be relating to the driver. But actually there are several more methods inherited from superclasses, such as set connection properties, set password, set URL and username. And it can be a little hard to work out, well, which of these do I need to set? So I've already kind of worked with this class, and I can tell you that the 4 properties we absolutely have to set are the driver class, the URL, the username, and the password. Now, none of these properties are complicated because they're the usual properties that we always have to set up when opening a database in Java. So let's have a go at configuring this data source then. So again, I'm going to have a block up here for my data sources. So I need to configure a bean. I'm going to give it an ID of, well, you can call it anything you like, but I'm going for data source. And the class is going to be, once again, we'll use the documentation so we can see it comes from this package. And the class name is Simple Driver Data Source. Now, as I mentioned on the caption, we've got 4 properties that we need to set. The first of them is called driver class. Now, again, I'm having to assume your previous knowledge here. If you've worked with JDBC extensively, you'll know that you always need a driver class in order to connect to that database. If you need guidance here, you can look back to our old version of this DAO, the horrible JDBC implementation. And in there, we have the driver name and the database URL. So for the driver name, we just need to copy this string here and to pop that into the value for that property. And then the next property name is the URL, which once again we can borrow from our old implementation. It's that long string there. And then we need the username, which for HSQLDB, the built-in username is the string SA, which I think stands for System Administrator. And for password, well, you can just leave that value as a blank. Now, I have an error here in my XML, and that's because it looks like on this line here, I forgot to close the XML tag. Okay, well, that's looking okay now. So a data source then, if you want to think of it like this, a data source is just a way of telling Spring how you want to connect to the database. Now, once we've configured this data source object, we need to inject it into the constructor of the JDBC template. So this is a constructor argument, and we're referring to our new object, which we call data source. Now, I know from my experience of teaching live courses that at this point, people tend to start getting quite confused. And it's certainly true that we've now configured an awful lot of beans, and it can be very easy to lose sight of what's happening. So I'm going to stop for a moment and recap what we've done so far. I'm going to go to the Spring Explorer, right-click on the XML, and have a look at the dependency graph. Now I'm going to start by looking at this graph here on the right-hand side. And we're interested at the moment in our book service. Now that is now the production standard book service implementation, which you know from the previous chapter is calling a production standard DAO. Now what we want this production standard DAO to do is to use the JDBC template to call the database for us. Now the obvious problem I can see from this graph is that we've now got a JDBC template. That's the work that we've just done. And the JDBC template is correctly connected to a data source. But you can see that we haven't connected this template to the DAO. It'd be great if I could just drag a line from there to there, but I can't. We need to do that in the XML. So the one thing I've forgotten to do now is if I go back to my DAO bean, I need to inject this template into the constructor of the DAO. So you know how to do that by now. Even if this is feeling a little complicated, it's still dependency injection again into the constructor. We want to pass in the argument, which is the JDBC template that we've just created. Now, just by doing that, if I go back to the graph, everything looks a lot more connected now. And as I say, it does feel like quite a deep stack of objects that we've set up here. But a quick review, our production standard service, where we might be putting business logic, is going to be delegating to a DAO, which is only going to have database operations inside. But we're using a JDBC template to simplify the database operations, turning a whole screen full of code into a single line of code. But the JDBC template needs a reference to this final bean, which is the data source, which contains all the information that Spring needs to connect, to physically connect to that database. So I think now, if we go back to our client application, at the moment the code we have is going to try to register a new book and then list all of the books in the catalog. Now we do have a database that we were using in the previous chapter. If I open that up in the standard Eclipse editor, I don't know what state your database will be in, but it looks like I just have a single book in there at the moment called War and Peace by Leo Tolstoy. So, and that's exactly the line of code we've got there. So if this works, we should probably see 2 copies of War and Peace in the system. Let's give this a run and see what happens. Well, I'm genuinely surprised that that ran through correctly, because we've done quite a lot of work here to pull all of this together. If you've had any problems, your first port of call, I think, should be the Spring Explorer, and check that your graph is hanging together correctly. And then if anything's going wrong, I'd probably check the values you've got inside your data source. But the important thing is, I'm going to check it again. We should now see 3 copies of War and Peace, and that's good. If I have a look in my JDBC DAO, I don't know if you remember, but in the constructor we create the table if it doesn't exist. So I think it's worth checking that. If I delete the 2 database.dat files and then run the code again, yeah, it looks like it's successfully able to recreate that table. So we've reached a really good point now. We've got this very clean implementation of a DAO, which is performing all of our database operations. And just to remind you, that's replacing a class, this horrid JDBC implementation that did work, but you can compare the two now. And for one thing, we've now taken out all of these driver names and URLs and passwords and usernames and put those into the Spring XML. And we've dramatically cleaned down how much code we need to write in these methods. And we also don't need the try, catch, finalies anymore, because Spring is going to diligently close connections if we have any problems. Now, just to be absolutely clear that this horrid JDBC implementation is now not being used, I'm going to delete it from the project. Now, I didn't do that on the first edition of the course, but I think that caused a bit of a problem with some viewers. They kind of weren't sure which one was actually being in use. But now that I've deleted that horrible implementation, I can now prove by running the client again that, well, our code is still running, so clearly it's using this nice, clean, modern version of the DAO. Now, going back to our XML, the big problem that we have with the code so far is that we're using this simple driver data source. Now, to be clear about this, this is not intended to be a production quality implementation of a data source. It's a quick get you up and running. And the reason it's problematic is that for every single database operation, a new connection is required, and opening connections is a very slow operation. Now, I have here a caption which is showing you the process that's happening under the hood when we're using that simple driver data source. We have on the left-hand side our client. The right-hand side here is cliched graphic representing the database. And here's our server code in the middle. So in there we would have our service, our DAO, and so on. Now, at present, the client's making a call, maybe to register a new book. And what the server is then having to do, and this is what's happening inside Spring, is a new database connection is being opened. I'm representing the database connection with this yellow oval here, and that animation I just did there was really, really slow. Well, it took a few seconds for that animation to run, which is exaggerated. We're still talking about fractions of a second, but that is still slow when you consider that our server is probably going to be having to handle lots of clients all accessing the system at the same time. And the other problem is that once this method is completed, so let's say that this connection has now successfully registered a book on the database, before we return back to the client, the server is going to have to close that connection. So I'm doing another slow animation there, and only when that's happened did the server return back to the client. So that whole process was very, very slow. Production systems will typically use some kind of connection pool. Now, just in case you haven't seen connection pools before, I've now reworked the graphic to show you the kind of thing that a connection pool will do. So a connection pool is something that we install onto our server. And what will happen is when we start the server up, the server will automatically create or acquire several database connections. Now, I have on the graphic here 5 of those yellow ovals. On a real connection pool, we could configure that to be as many connections as we think we need. Now remember, the server's only just starting up. We haven't even done anything yet, but the server has gone ahead and sort of preemptively, in advance, opened those database connections. Now that process was slow. It was kind of like 5 times slower than the opening we had on the previous caption. In fact, let me run that animation again. This is really slow, but that's only happening when the server starts up. We don't mind that being slow, because now when a client comes along, and again we'll go for the client is going to register a new book, the client makes that call to the server, but now the server, because we've installed this connection pool, the what the connection pool will do is, instead of opening a new connection, I'm sure you can guess now, it will just find any of those 5 connections that is currently not being used, and it will kind of, if you like, connect the client to that free connection. It hasn't had to open it, it's just had to borrow that connection from the pool, which is a relatively fast process. So now we have a database connection, the database operation can be performed, and the next speed up is, now that we've finished with that connection, we're not going to close it, we're going to leave it open in the pool. So the server can very quickly return back to the client. This connection is now still open and can be used to service future requests. So all of that magic was done by this software that we put on the server called a connection pool. Now, a connection pool is quite sophisticated because it has to be careful to make sure that only one client at a time can access any particular database connection, but that's one of the requirements that we have of connection pool software. Now, in the first few years of Java, a problem was that the only connection pools you could get were expensive commercial products that you could only buy from vendors. But soon the open source world produced a few different implementations of connection pools. And wonderfully, to stay consistent with the Java library, all of the implementations, or at least all of the popular implementations in Java, use the same data source interface that we saw earlier. So that you're familiar with the names, here are a few of the open source implementations of connection pools that are available at the time of this recording. The first one is called DBCP and comes from the Apache project. We also have one called C3PO. The C must stand for connection and the P stand for pool. Obviously, that's a Star Wars reference. There's one called Proxul, and the other big one would be the Tomcat connection pool. Now, on this course, we're going to use DBCP, but I hope you're getting the flavour of this by now. All of these 4 products implement the same interface, so you can switch from one to the other by just downloading a new jar file, then changing the class name that you're using in the Spring XML. Then you would find out from the reference manual of your new connection pool provider what properties it's going to need, and then you would add those into the Spring XML. Now, I must be careful here. Since we recorded the first edition of this course, there have been complaints in the Java community that DBCP doesn't perform particularly well, and it is a rather old product, and a lot of people don't think it's of a very high quality. So I'm using it here on this course just to stay consistent with the first edition of the course. But, you know, having said that, DBCP is used by hundreds, maybe thousands of projects around the world. In fact, we at Virtual Pair Programmers do use it on our database on the Virtual Pair Programmers website. Now, one of the things I know about DBCP is that its default properties are really bad. So you need to give it good values. Now, I won't be worrying about that here on the course because it will work with the defaults, but I have written a blog post at the URL you can see here, talking about the properties, the values that we use on our live Virtual Pair Programmers website. So check out that post if you're interested. In our lib directory, we've always had this jar file here called commons dbcp. As long as you have that jar file together with this commons pool jar file, then you effectively have a connection pool ready and available in your project. What we need to do now is to use this connection pool by configuring it in our XML. So this is where we configured the simple driver data source earlier. All we have to do here is to change this class name and to switch it for the class name provided by the DBCP projects. Now, of course, we need to find out what that class name is. To do that, you really need a little bit of knowledge about the DBCP project. So off camera, I've already gone to the commons.apache.org website, and I found here the Java doc for DBCP. And I can tell you that the class that implements a connection pool in DBCP is called the basic data source, which isn't really a very nice class name, to be honest. It doesn't really suggest what it's doing. Let me be clear about this. The basic data source is really a connection pool. And you can read the Java docs if you're interested. I think the important thing is it's telling us here that we configure this connection pool via properties. And that means we can configure this in the Spring XML. The first thing I'll do is copy the package name and transfer that into the class here. And then I need the class name, and Spring now knows it needs to instantiate an instance of that connection pool. The next thing we need to do are to configure the properties. Now, can you see, if we have a look on the left-hand side here, I am getting an error in the Spring IDE. And that's probably because on this connection pool, there isn't a property called driver class. And we can check that by scrolling down to the method summary, and we're looking for the set methods. Can you see here? Their method is called set driver class name. So it's just a simple case that because this is a different implementation of a connection pool, it can have different property names. So I've just changed that there to driver class name. But we're actually quite lucky now. It's a coincidence, really, that the basic data source also has a property called URL, username and password, exactly as the Spring version did. So in fact, we can leave those three properties in place. Now, these four properties are enough to make the basic data source work. The rest of the properties are there to configure things such as how many connections should this connection pool have open at any one time. So, for example, there's a property there called max idle. This configures how many connections can remain idle in the pool. That means just how many are sat there doing nothing. If I click into that, it's not telling me here, because really the documentation's not good, it's not telling me here what the default value is. But I'm going to assume that there is a good value. As I mentioned before, if you're going to use this connection pool in a production system, you want to put some good values in for those. And again, you can check out my blog post for details on that. But for our project, these four values will be sufficient. Now, I know I've only made a small change there, but I still think it's worth checking out the Spring Explorer and having a look at the graph. And that's looking good. The book service is delegating to our DAO, which is using the Spring template to simplify everything, but it's now using a production quality connection pool. So we would see better performance by using this data source. Now I'm going to run the client again. And I think just to be safe, I've just refreshed the project there so that I can see my two database files. And I'm going to delete them. So we're starting from a completely clean, fresh project. And if you remember, the client's doing nothing more than registering a new book and then listing all of the books in the catalogue. Let's give this a run. And that looks okay. We're seeing that book registered. I'm going to run it again though. And that doesn't look so good because I've run it a second time and I'm still only seeing one book in the system. Now, we're expecting persistence here, so every time we run the application, we should be seeing an extra book added. So what's going wrong here? Well, if I go back to the Package Explorer and once again refresh, we have a clue here. Can you see that there's 4 database files now instead of 2? And one of them is a good clue. Database.dat.lck. That's a lock file, and it's telling us that the database is still open and has not been closed down. Now, because this is a file-based database, when you've finished working with the database, you need to close it down. That's the only way that HSQLDB can close the files properly. So this suggests that something's going wrong. Now, the reason that this isn't working is quite a subtle problem. I remember the first time this ever happened to me years ago now, and it took me a long time to work out the problem. The source of the problem is that the basic data source, the connection pool that we're using, needs to be told when to close. The basic data source has a method. I'll need to scroll down quite a long way. In fact, here we are. It has a method called close. Now, the intention of this close method is that you call it when the application is completely finished. And that means not when you've finished with the database connection, but when you've finished with all of the database connections and you want the entire pool to close down. So if you were writing a web application, for instance, you would need to call this method when you're shutting the server down. Now, what you could do in your client's application is, before we close the Spring container, we could, right here, look up the data source bean from the container and then try to call its close method. Well, I think that's going to be a little bit laborious, and we would have to remember to do it at the end of every application that we wrote. But I have a better suggestion. It would be nice if we could get the close method to be called automatically by Spring when we close Spring down. Because remember, this last line of code, we've had that in our client since the start, is the method telling Spring to close down. And in fact, we can do that. This relies on a bit of Spring that we haven't yet covered, is that for any of these beans, we can specify here in the XML, this is the line where I'm defining the data source bean. We can specify a destroy method. And you do it exactly like that with destroy -method. You'll notice that the IDE has made this a different color to emphasize that it's recognized. And we can plug in here the name of any of the methods that exists inside this bean. And the deal with that is, when we call close on the container, Spring will make sure that this method is coincidentally also called close, is called on the data source. You don't often need to use this, but in some circumstances, when Spring is closing down, you do want some kind of cleanup to take place. So that's a really useful feature, and it avoids us having to manually go through our beans calling methods at the end of the program. Well, that's good only if it works. I think actually before I run it, I'm going to delete those 4 database files. We might as well start from a completely clean system. Okay, well, we expected that to work the first time, but if I now refresh, oh, that looks good. We've only got 2 files now, which suggests if I run a second time, great, 2 books in the system. A third time, just to be sure, yeah, we've now got 3 books. Now that reminds me that there's a further improvement that we can make. Do you remember that in our database access objects, in the constructor, and this is where we're injecting the template, as soon as we've injected that template, I've put in a try catch block, and the idea there is that we'll try to create the table, but if that fails, we'll assume the table already exists. Well, this works, but it's perhaps not perfectly elegant. I'm not sure really. It's okay, but sort of doing actions inside the constructor is a little bit unusual. In the constructor, we really just want to be setting properties. It would be much cleaner if I could cut that code out and place it in, it could be a public or a private method, but a regular method called createTables. I'll just paste that code in. In Eclipse, you can do Control-A to select all the code and Control-I to re-indent all of the code. That kind of just looks nicer because it's now in its own method. But of course, now this method is never going to be called. But you might have guessed where I'm going with this now. If I go to the XML file, you know that we have a destroy method that Spring automatically calls when Spring is finishing, but we're also able to do the reverse. As we're working here on the book DAO, if I go into the book DAO definition, I can also supply an init method. Of course, that stands for initialization method. In our case, this is going to be createTables, and that's telling Spring it needs to call that method once it's created this book DAO object, i.e. at the start of the program's run. So that's going to call this private method. By the way, Spring can call a private method. It just uses reflection to do so. No problem there. And so we don't need to manually call that method. I won't be using the init and destroy methods very often on this course because you don't need them very often, but they're very elegant when you do need them. Well, let's check that that runs. I think again I'll refresh and delete the database. Of course, this will crash if the createTables method doesn't run, but yep, that's running well. And if I run again, great, we now know that the createTables method is definitely running. Our DAO is now up and running and almost production quality. We've seen what a data source is, that is standard Java, but every leading connection pool implements the data source interface. And that's why the JDBC template works with any data source implementation. There are several implementations and I'll leave you to choose your own. Be aware that the DBCP that we're using on the course has a bad reputation these days, but I believe it's okay as long as it's well configured. Do check out my blog post for details. We have to be careful to clean up our resources. We need the destroy method to make sure the connection pool is properly closed. You'll find that even in production projects that they often don't bother with that destroy method. And in a way, you can get away with that on a normal database. We needed to close properly because the database gets locked. Now that won't happen with Oracle or MySQL, but without closing properly on those, you might leak connections instead, which can be a problem, so you should always include a destroy method for data sources. Well, the next chapter is going to cover the rest of the basic support in Spring for databases. We'll be looking at how to manage exceptions, and only if you're interested, we'll be talking about JNPI. So I'll see you again for that.